This talk is a project update from the Garden Windows team on our goal to achieve pragmatic parity for Windows containers with our Linux counterparts. We're going to cover a few different tracks of work today, including enabling custom certificate injection, ensuring graceful process termination, maintaining route integrity and mutual TLS, running Envoy on Windows, container-to-container networking, and supporting iReadme for Windows. My name is Sophie Wigmore. I'm an engineer on the Garden Windows team.
And I'm Matt Horan, also on the Garden Windows team.
The Garden Windows team is responsible for providing Cloud Foundry operators and developers with a similar experience between Windows and Linux, whether that be using or managing servers or containers. What do we actually mean by pragmatic parity with our Linux counterparts? You've probably heard this phrase many times from other Cloud Foundry Windows talks, but just in case you haven't, a quick refresher. Cloud Foundry is built upon Linux-based components, and when it was first released in 2011, it only hosted Linux-based applications. This made it ideal for cross-platform applications like Java, apps written in Java or .NET Core, but apps like .NET and other Windows applications were kind of left out of the equation. That's where pragmatic parity comes into play. In order to support these applications, we needed the Windows operating system to power our Diego cells. As we started this work, we discovered that the features needed by .NET apps are actually quite different from the features needed by Linux applications. As we worked on achieving parity with our Linux counterparts, we had to be very pragmatic. While our implementations would be quite different, we still needed to achieve the same experience for Windows users as they get with Linux. Our talk today is about our ongoing work to resolve the feature disparity between Windows and Linux. That being said, the first feature we wanted to discuss is custom CA certificate injection. A Cloud Foundry user may want to ensure that their applications can only connect with secure endpoints that they've approved. This is especially important for applications with sensitive information. So he or she can now provide CA certificates via the CF deployment manifest, and this will enable their applications to connect with secure endpoints. First, the Linux implementation. Operators, as I said, add their custom certificates through the deployment manifest, and then Bosch will automatically load these certificates directly into the root file system in the container trust store, and ta-da, your apps can communicate with the secure endpoints. We would have liked to do the same thing on Windows, but it wasn't this straightforward because not only do you need to update the root file system, but on Windows you also need to update the Windows registry. There's no easy way to manually update the Windows registry, so we had to implement kind of a workaround to get this functionality working. So the way our implementation works is we start with the clean root file system, and we bring up a regular old container with that. Then we take the certificates and we import them into that container, and this takes care of the Windows registry update issue that I just discussed. And then once we add those certificates into the container, we can then export the top layer of that image, which contains the certificates that we just added. With this OCI layer, we can add it back on top of our original root file system. So now any subsequent containers that get spun up off of that root file system will contain the certificates. If the user decides, I don't want certificates anymore, or I want to switch them out, it's as simple as just removing that top layer and going back to our clean root file system. All right, next we have a demo. How do I do this? Let me make it full screen. Cool, so up on top we have a CF deployment with 2 Windows cells, and I'm just getting the Bosch manifest. And we're just going to open it up, and I'm going to show you that the rootfs job has no certificates in it right now. So here you can see the Windows 2019 FS job. This is where we will eventually add the certificates in the next step. So with this deployment, I'm just going to push an application. Here we have Nora, which is just a sample .NET app. And now we can CF SSH into this application and run a PowerShell command to see if we have a custom certificate. In this case, we're going to be adding a Diego CA certificate in the next step. So here you can see there's no output. We don't have any custom certificates. And we can exit out and go back into the manifest and add some custom certificates. So here we have, again, the rootfs job, and I'm just going to paste in a couple single certificate. You can add as many as you want. We'll save that, and we're going to redeploy with that new manifest. Here you can see the diff with that added certificate. Cool, so our app should still be running, and when we cf_ssh back in and run that same command, we should see that certificate that we added. And there it is. Cool. So the next feature that what happened there? Thanks. All right, so the next feature we wanted to discuss is graceful shutdown. When a user CF stops their application, graceful shutdown allows us a period of 10 seconds to save the state of an application and its processes before things get torn down. Without proper shutdown, pending processes and other connections can linger around, which is definitely not a good thing. Apps get left in weird states, data inconsistencies can occur, and failures to bring processes back up are really common. This is also a really useful feature for legacy applications and applications that might not be so cloud friendly because it allows them to run a little bit more healthily on CF. The way this works on Linux, roughly when the user issues a CF stop, under the hood, Diego will issue a process signal command to the Linux kernel. A sigterm process signal will issue the graceful shutdown period of 10 seconds, and then subsequently a sigkill process signal will issue the container to be destroyed. On Windows, the implementation is a little bit different because process signals only just came out, and we weren't sure whether we could use them to implement graceful shutdown. So instead, we found a different way to emulate this process signal logic. So on Windows, instead, we have control shutdown events. When the user issues that CF stop, control shutdown event gets issued, and apps can be configured with a control shutdown handler in order to handle that control shutdown event. Then it gets a period of 10 seconds to shut down all of these application processes, and the Windows registry will also get updated to wait a period of 10 seconds before it tears down the container. It's important to note that if your application doesn't have that control shutdown handler, you won't be able to get that graceful shutdown period. So we've created a lot of documentation in the .NET cookbook for people to use when they're trying to implement that handler. An important distinction between our implementation and the Linux implementation is that on Windows, it's a hard-coded period of 10 seconds, whereas on Linux, it's configurable. Cool. We have another demo. Screen. Cool. So up top, we have an app called GoShut. It's configured to just have a little bit more verbose logging. And on the bottom over here, we're going to get the logs of the application. And then we're just going to issue a CF stop. And we should see an output of 10 seconds of graceful shutdown time. So here you can see it gets the signal, and then our application is going to print out every half a second of time, just so you can see that full 10 seconds. And then the container gets destroyed.
All right, so one of the other feature disparities that's existed between Linux and Windows is around route integrity and mutual TLS. So before route integrity existed, the Go router would proxy connections directly to the app instance via the cell's IP in plain text to a port that was exposed on the cell. This worked fine for most cases, but as you can imagine, there's a little bit of complexity in maintaining a routing table and getting routes into the Go router. Specifically, we had to deal with, how do you make sure that routes don't get routed to the wrong instance, hence route integrity. The way that this used to be handled was simply by adding a TTL to the route when it was added to the route table, and then the Go router would periodically prune those routes from its routing table. This worked fine, but we thought that there could be something better. And on Linux, we did implement something better with route integrity. So we started installing an Envoy sidecar in every container and hooking that up to the application's instance identity credentials so that the instance could be identified via the Go router. With the route integrity in place, Go router will verify the certificate that's presented by the app when it reaches out to that app. And if the certificate does not match what's expected, it won't route to that instance. It works pretty well, but it was only for Linux. And so for Windows, we still had this TTL-based route expiry, which wasn't super awesome. We also didn't have support for mutual TLS to the container, which is something that was enabled by Envoy. And this was particularly disappointing for Windows because with Windows containers, we also don't have support for IPsec. And so there was no way to secure the traffic between the Go router and the application unless you were using TCP routing. So what is Envoy doing in this configuration? When the Envoy is installed in the sidecar container, the Go router can initiate that TLS handshake to the Envoy. The app instance credentials are presented to the router, and then the router can actually verify the app GUID, the space GUID, and the org GUID. So we know that we're talking to the right instance. So if the GUID matches, the Go router will go ahead and forward that HTTP traffic to the Envoy in that sidecar, and the Envoy will then forward that traffic to the app over localhost. So we have a fully secure TLS handshake through there, and we verify that it's the right instance. If the GUID doesn't match, the Go router will transparently try another instance that it knows about, or if it knows about no other instances, it will return a 503 to the user. So this is great, because now we can stop using a TTL-based route table for our instances, and we also get that TLS to the container, and optionally mutual TLS. So this must mean that we got Envoy working on Windows, right? Well, not quite, but nginx works great on Windows. And so we were able to get nginx working on Windows, and we'll talk a little bit about how we did that. So what is nginx doing here? Well, very similar to the Envoy sidecar that we have on Linux, we've got an nginx sidecar. We've also got a envoy.exe in that sidecar, which is a little Go program. It watches all of the Envoy configuration files and generates corresponding nginx configuration files. So everything from the Envoy dynamic certificate configuration to all the endpoints that you've configured for your application. Say you're listening on port 8080 and 9090 and whatever. All that dynamic configuration, well, that all gets written to the Envoy config file. And we have a parser that writes that into an nginx config file. And we can just start up an nginx running in a sidecar. So this provides us with both the route integrity that we were hoping for, as well as optionally mutual TLS. So there are a few caveats with this solution. So first off, when you turn on mutual TLS with the Envoy, you're going to get subject alternate name verification of client certificates when you're using mutual TLS. We determined this to not be a blocker for releasing this feature, although it is a thing that doesn't work. And so what this means is anything that's trusted by anything that's signed by a trusted certificate will be accepted by the Envoy, or the nginx rather, running in this sidecar. It's not really a huge security problem because that should be a very limited certificate that you're trusting there. In most Cloud Foundry installations, it is only used by the router, but it's something to be aware of. There's no dynamic configuration interface for our nginx. So we are parsing the static Envoy SDS configs that Diego generates and drops in a bind mount for your app. That works fine, but Envoy also has this dynamic configuration interface, which is great and is used by Istio, but we didn't go and implement that in our little fake Envoy. Sure, there are certainly other things that don't exist and aren't implemented that we just don't know about. So this is a beta feature. Let us know what works and what doesn't. But why didn't we wait for Envoy? Well, we've heard from a lot of Cloud Foundry operators and users that they wanted this feature now, or maybe 6 months ago. And so we wanted to get something out there that solved some of the problems like IPsec not working on Windows. Our Envoy porting efforts are still ongoing, and I keep saying it'll be done in 6 months for probably the last year. So you can imagine we're not quite done with that. Also, Envoy performance is not fantastic. The nginx in the sidecar also doesn't have the best performance, but it's certainly better than not having anything in that sidecar. And right now, the Envoy that we have built, very alpha Envoy, is not battle tested at all. Nginx has been used on Windows for a while now, and even though it has some performance problems, it's usable. So you can get started today. There's a ops file that you can grab from CF deployment to add the nginx sidecar to your Windows apps. One of the other features that's been missing from the Windows stack is container-to-container networking. So we originally had investigated bringing Silk support to Windows, and I've talked about this a few times in the past. And there were a number of challenges that were encountered. We determined that it was just not feasible to try and bring Windows Silk support, and in general, container-to-container networking support to Windows. But longer term, there's a conversation around moving towards a higher level abstraction for applications talking to each other in the service mesh. And so if we can get Envoy working on Windows, then we can enable service mesh on Windows. And who really cares about what's below the service mesh? Maybe you have container-to-container networking. Maybe there's an underlay network that connects all of your containers to each other. It shouldn't matter. We're going to hide that all behind an abstraction, and everything looks like it's in the same foundation when you have a service mesh. This is also great when you have applications deployed across application runtime and container runtime, and you need them to talk to each other, or you need to do some really interesting policy-based routing that isn't possible today. And so we're just continuing to invest in that Envoy port. We've got a pair of engineers working on it right now, and they're making a bunch of progress. Back to you.
Cool. So the final initiative that we wanted to discuss in relation to pragmatic parity with Linux is Project Irene. In case you haven't heard, Irene allows pluggable scheduling for the Cloud Foundry application runtime, so a user can choose between Diego and Garden or Kubernetes as their container orchestrator. We have experience with Kubernetes on Windows and the previous implementation of containers on Windows, so we've been working with the Irene team to determine what blockers exist to getting Irene up and running for .NET apps. Some challenges that we've seen so far are using Docker on Windows. The Docker export function doesn't work, well, as far as we've seen. App staging, so generating the droplet on Irene, routing, and converting app droplets into the OCI image layers have been some blockers for us. That concludes our talk on achieving pragmatic parity for Windows containers, and if anybody has any questions, we have some time left.
So how many months until that Envoy?
Definitely 6 months.
Are you working on it by yourself, or is anyone else? I'm sure that it must be.
Yeah, so we initially, Microsoft had started the question was, are we working on the Envoy port ourselves, or is there anybody else working on it? So Microsoft had initially started the porting effort maybe a year and a half ago, and we started working with them very early on and starting to contribute to that, kind of take what they had started and get it upstream. They don't have anybody working on it currently, and so we're the only 2 people working on the Fort at this time. There is definite interest in the Envoy community about getting Windows support working. It's a question of like we really need at some point a Windows expert to help with some of the performance problems. We're basically going to have to swap out the eventing model that's used for handling connections, specifically for Windows. That's going to be a huge undertaking. That's what I mean by their real performance problems. And that's where like we either need Microsoft or like somebody with 10 or 15 years of Windows socket programming experience to help with that. So hopefully we get that at some point.
Sophie, you said Docker export doesn't work, but is it supposed to work?
I think so.
It's a bit unclear. There are things in Docker that you think should work or seem to work, and then it doesn't work the way that you expected it to. But Sophie, you talked a little bit about this. Like, we might be able to just avoid this whole problem by relying on future replacements for the bit service. So Irene uses the bit service today, but in the future, if we're not relying on that, it won't be a problem. Fingers crossed. All right.
Thank you.
Thanks.